How's everyone doing tonight? Good? Awesome. Well, thank you everybody for coming and listening to my talk. Today I'm going to be talking about unlocking the power of iteration. Oh, let's make sure it's working. There we go. So a little bit about me before we get started. My name is Clement Ho. I am the front-end engineering manager at GitLab. We have a few of those. I'm one of them. My Twitter handle is clemmakesapps. So if you ever have any questions about my presentation or about GitLab or about Austin, USA, love to help answer them. I don't speak Portuguese, so I can't answer in Portuguese on Twitter, but we can make it work. And I'm based out of Austin, Texas in USA. So who here has heard of GitLab before? Raise your hand. OK, most people. That's cool. Well, if you don't know what GitLab is, we are a single application for the entire DevOps lifecycle. So we make it easier for you to develop software. What is iteration? So let's start off with that. What is iteration? So iteration is the repetition of a process or utterance. That's what the dictionary defines it as. Basically, it's something that repeats itself. Iteration in real life. So an example of iteration in real life is working out, going to the gym. That is something you do repeatedly every day, hopefully, and eventually you become really strong and you can start doing cool things like that. Iteration in software in real life is what you might imagine, a for loop, very simple, just iterating through 10 and logging it. Iteration around us in iOS. So iOS, very popular. This is just a screen from iOS 1 to 7. We're now at 12. But you can kind of see the progression over the years. If you look at, for example, the Notes app, in the beginning it was very trying to be more like real life, more skeuomorphism. And now you see more flat design. So you see the evolution over the years. And each year, it's kind of slightly progressing, moving towards that. So with that, I want to remind everyone that iteration is all around us. If you look carefully, you'll find it. Iteration is also intentional. It's something that is intentionally decided by different people, by the company, by the teams. It's purposeful and deliberate. It's not something you do just because you roll a dice. It's something that you have to really decide to do and go all in. So traditional software lifecycle is the waterfall method. And this is kind of the very basic version of it, just the idea of requirements going all the way to maintenance. It's the idea that software is a one-way flow, where you do it once and then you're done. This is not iteration. Depending on your company, maybe you have a successful version 1, you might have a version 2 and start over the waterfall cycle, but this traditional cycle is very long. It's months and months and months. So to me, I think that it's like the prayer method. You pray that the waterfall will hit in the right places and that when you start off in the beginning, you'll know exactly what the customers want, and you'll deliver what they want, even though you take so long. But it's hard because customers don't know what they want, and sometimes they don't communicate it. So what are some examples of not iterating in real life? So Juicero is a startup in the United States, and they raised over $120 million. And that's a lot of money. They were backed by really big venture capitalist firms like Kleiner Perkins and Google Ventures, but they had their own problems of not iterating. So Juicero was a company that built this machine that could make juices for everyday consumers. So the idea was you get a juice packet in the mail, you put it in the machine, and you get juice. And in America, in the United States, juice is like really one of the things that everybody likes to spend money on. They wanted to be like Keurig. Keurig is very popular in the United States, and it's a company that's worth over $14 billion. It's the idea of putting the capsule in the machine and boom, you get coffee. So they're trying to capitalize on that market for juices. But they didn't iterate very well. And this is what happened. So when they first launched, the machine was $400. And people realized that you could squeeze the juice packet and get almost just as much juice as the $400 machine. And so look, it's almost the same. And so this company spent a lot of money doing R&D, high-pressure machine to press the juice, but they didn't iterate. They didn't go step by step to consumers. And now they raised $120 million, and it just all went by. So a lot of times when we're building software, we always think we know what we're going to build, and then slowly after we build it, we realize that we need to change a little bit and realize that what we should be building is a little bit different than what we intend. So with iteration, we can do shorter iterations and get closer to where we're trying to build, where the customers can actually find value, the users can find value in your product. So this leads to the Agile Lifecycle, which hopefully lots of people have heard of it. Raise your hands if you heard of Agile. Okay. All right, almost everybody. So Agile is very interesting. Everyone has their own definition of what an Agile lifecycle is. You throw out a lot of fancy words like Kanban and sprints and Scrum, and you say all these fancy words, makes you look like you really know everything. But nobody really knows what Agile really is. Everyone's definition is a little different. So what is Agile? So if we had to boil the Agile lifecycle, it's the idea of going through small sprints, which is the circle, where you go from plan, design, build, test, and review, and then you launch. It's the idea of launching multiple times for a first version, rather than the waterfall, where you go through all that and do one version. So this looks a lot like a repetition of a process. It looks a lot like iteration, like we defined earlier. So I would say that iteration is agile, or rather, agile is iteration. And iteration is a competitive advantage. It can help you deliver software faster, better, help your company make more money, make you a better engineer. So Sam Altman, who I believe is the current president of Y Combinator, a very successful accelerator in the United States, he tweeted that the #1 predictor of success for a very young startup is the rate of iteration. So if the rate of iteration is so impactful for a small startup, it could also be very impactful for you as an individual. And so with that, iteration is a different way of thinking. And let's talk about that. How do we start thinking in iterations? How do we unlock the power of iterations? We do this by doing the smallest thing possible, and we ship it as quickly as possible. So previously, something that took 1 year, let's ship it in 1 month cycles. So let's imagine we have a big task. Let's visualize it with this chart. And we break it down to 4 pieces, and we try to do one part at a time. And it enables you to move fast and also collaborate and delegate different subtasks. So one of the values at GitLab is iteration. And this is in our public handbook, because we're very big on transparency. So if you want to check it out, it's there. And the quote here is, "You are doing it right if you're slightly embarrassed by the minimal feature that shipped in the first iteration." So let's go over that. Your first iteration should need improvements, and it should not be perfect. And it also should not be broken. So a lot of times people think, oh, iteration, let's just ship something, and it's broken. That's not good. That's not a good iteration. So this is challenging because we grow up learning to train for perfection. We enjoy watching these videos where people shoot hoops perfectly, and we go through school trying to get 100, trying to get that A+. And so we've been conditioned to train for perfection, but that conflicts with the concept of iteration. It makes it hard to iterate when you constantly want to be perfect. So the solution is to create a minimum viable change. So a minimum viable change is something like the bottom. So the idea of you're building a car, but you first build a skateboard, and then you slowly move towards the car. Each step is still useful for a user. It's still a transportation device. It's not like the first part, the top part over here, that you start off with a wheel, and then you slowly get to the frame of the car, and then you get a car. Those steps, only the car is useful for a person. Everything else before is useless. I would say that those parts are broken. They're not a good iteration. So Paul Graham, who is the co-founder of Y Combinator, he said a famous quote that says, "Do things that don't scale." And that's something to think about in your first iterations. It's important to iterate quickly so that you can optimize for the speeds and results. So you're trying to do small iterations to figure out what the right solution is. And then after you have the right solution, you can start scaling because you have your results. So another way to think about iteration is to also start considering an environment where decisions are easy to reverse. So a lot of times in companies, we have very extreme processes, and that makes it hard to iterate because you can't reverse in case something goes wrong. So iteration is meant to allow you to ship fast and revert fast in case your ship's about to get destroyed like that GIF. So it's important that when you're iterating to be able to revert in case of terrible things. It's also important to remove unnecessary bottlenecks in approvals. So this is tied very similar to reverting. If it takes a long time to get approval, to do your next iteration, to push to production, that's going to hinder your iteration time and make it harder to iterate quickly. So an interesting quote that the CEO of Amazon, Jeff Bezos, said one time in his company meeting, this is published online, and he said something about the concept of a two-way door. A two-way door allows you to return to the state you had before. So you can take one step forward, and then you realize you don't want to go back that way. You can turn around and go to the other door. So Jeff Bezos is saying that we should think about two-way door decisions. These are reversible decisions, and we want to encourage employees to make them. We should make it very easy for people to go forward and come back if they need to. There's no reason to add approval processes to simple situations, as long as you can revert them. So another thing to think about with iteration is also be willing to sacrifice short-term gain for long-term gain. So that's a very interesting concept, but let me show you how we do that at GitLab. So here is a before and after of some changes in GitLab. Recently this year, we upgraded Bootstrap from 3 to 4, and Bootstrap 3 to 4 has a lot of breaking changes, and so if you look, there's a lot of subtle UI differences between the top and the bottom. For example, the outline is darker on the bottom, and the spacing between the checkbox and the label is a little different. So this is a situation where after the upgrade, we realized, hey, we have these small visual regressions. But we decided that we were going to sacrifice this short-term gain, the short-term effort to fix these for the long-term gain, which was actually to start rewriting some of our CSS so that we can eventually follow a design system set for GitLab and eventually replace all of our UI to be consistent. So we decided that it was more worth our time to start moving towards our new CSS rather than trying to fix the UI to make sure it looked 100% the way it did before. So how does GitLab encourage iterative thinking? So GitLab, we have a monthly release. Every 22nd of the month, we release a new version of GitLab. This creates rhythm. When you have rhythm, it actually allows you to start thinking more iteratively. It starts helping you think in smaller chunks. And so I encourage you to find a rhythm that fits you. Nat Friedman, who's actually going to be the next CEO of GitHub after the Microsoft acquisition, once talked to our CEO at GitLab and said, we have a low level of shame, very intrinsic, very core to our culture. What does that mean? It means that at GitLab, we're willing to ship something that isn't perfect. Not broken, but not perfect either. And iteration is everybody's responsibility at GitLab. So if you want to adopt iteration well in your company, you want to make sure that everyone can contribute to it. Anyone can input and discuss, because each person is important, and each person can input and show you different parts of your iteration that could be improved. Iteration, as I said before, is also a company value at GitLab. And that encourages accountability. It encourages us to tell our CEO, hey, we need to decrease the scope, we need to decrease the iteration, let's just ship it now. It also encourages the CEO to do the same for anyone in the company. So there's a mutual accountability, a mutual goal to ship fast with iteration. So here are some really cool quotes that we have from our Slack channel, just showing you a little bit insight into GitLab. And we're really big on iteration, and we really mean it. So we constantly encourage each other. We say thanks for iterating, thanks for having a low level of shame. All these things are really great. It helps foster the concept of iteration, making it so that people continually find ways to iterate well. And we also have leaders encouraging us to make iterations, and that's really effective. When you have leaders who demonstrate iteration, they have great impact on the organization. Whatever is done on the leadership level will eventually trickle down. So I encourage you, if you are a leader, to start thinking iteratively, and if you're not a leader, start talking about it, create those discussions. So what are some real-life examples of GitLab iterating? So GitLab has a lot of features. We have a lot of verticals. This is just a glimpse of what we have. One of the verticals that that GitLab worked on, that I worked on, is the portfolio management, and we also call that epics. Epics is the bird's eye view for executives and the companies to see what's going on in the code and the projects, cross projects. And our first iteration for epics was quite embarrassing. It was embarrassing because it was very simple and it looked just like issues. And I can say that because I wrote this iteration. I wrote the first iteration and it shipped about a year ago. So it's embarrassing. The only new code that was added at this time was the sidebar. Everything else was reused, which is a good thing. It's not bad to reuse code, but the UI was very similar to what we had before. And this is a screenshot of issues. It looks very similar. There really is not much a good use case for users to really want to use epics versus an issue. Issue was much more of a first-class citizen than epics. First iteration had no commenting. You create an epic, the title, description, and that's it. There was no shortcuts, no attachments, no labels. It was kind of not useful. But it was a good embarrassment, and it allowed us to iterate quickly. Once we started shipping small versions of epics, we actually had sales teams in our company start talking to customers, telling them, hey, check out epics. This is our vision for where we're going. And not only that, they could start seeing as we progressed and iterated and actually got to give us feedback on what we were building to make sure we were building what they wanted. And so before we actually had a first real version of epics that was useful, in my opinion, we already had customers signed up to pay for epics. And now today, epics are first-class citizens. So the team that has worked on it, I haven't been working on it for a while, but the team that's been working on it has really made it really impressive. Every month, there's a new version, update, iteration, and they're now full-fledged, different than issues. No longer an issues clone. You can now comment on it. It now is more of its own self. So future iterations of Epic. So I wanted to highlight this just to show you how we iterate and how we have different features that we want to add on as we improve over the future. So some of the things is like promoting issues to epics, confidential epic, adding epics to search, and creating a child epic from epic. And one of the cool things about GitLab being transparent is that you can actually check out these links and actually follow along our iterative cycle. I will post these slides later on, and so you can check them out. So earlier was an example of iteration in product. We also iterate in development as well. So earlier this year, we had to prepare for a jQuery 3 upgrade, and it had breaking changes. So we wanted to iteratively prepare ourselves for this upgrade. jQuery 3 provided an upgrade guide from the jQuery team, and we took that guide and we broke it down to the different parts that it talked about, the different sections. And then we broke them down to different tasks, and different front-end engineers worked on different parts, and some of them were able to work on it in one release, and some of them worked multiple releases, but with a collaborative effort and breaking it down to smaller pieces, everyone was able to work together and ship this very fast. Another example was we were recently refactoring code for code splitting. So for those of you who may not know what code splitting is, it's the concept of certain web pages where previously you would load all the scripts for a page. And now with code splitting, you only load the code that is executed on that page. So really useful for reducing the amount of content you're letting your users download on the browser. So we had this thing called dispatcher.js. In dispatcher.js, we had this giant switch statement that did certain code based on the page. So issues page would call issues code. Merge request page would call it merge request code. And so what we did was we broke it down to smaller iterations. Each engineer worked on different cases, and whenever they had time, they would start refactoring those specific cases into a separate JavaScript file that could be asynchronously loaded. And over time, we were able to get rid of this giant switch statement and actually have code splitting working in our code base. Another thing that we did recently was writing a new component library. So that's a very huge endeavor. Our first version of this component library is called GitLab UI. And it didn't really have very much to it. We had auto-publishing to NPM. We had auto-deploying the docs, so you could look at the documentation, and image snapshot testing for visual regression. These were different plugins that we used. And we also created a simple component to integrate with GitLab, just to make sure it works. This is what it looked like. First iteration, not really very much. You have the progress bar as our first component to integrate, but it's not very useful, but it works. Our current version, which is currently about 2-3 months since we first started, we now have 8 components, and we actually have full documentation and an online playground for components. And all of this work that were done by a few engineers, not even the entire front-end team at GitLab. And this is what it looks like now. So much more useful, a few iterations down the line since the beginning. And you can now see how to use it and information about it. And one of the cool things is you can actually start manipulating it. So this is the playground that I talked about earlier that is very useful for engineers to test out our components before they implement them. So future iterations of GitLab UI, we want to add all our components on there. We want to add a localization. And we also want to add tools to improve the process for contributing. We want to make it easy for the community, because it's open source, as well as for our other coworkers at GitLab. So you might ask, why didn't you add linting? Why didn't you add danger or CLI tools to help build these components early on in the first iteration? Shouldn't it be necessary? Well, that's something that each team needs to figure out. For us, our first iteration, that wasn't as prioritized. We wanted to get something running before making it easy for other people to contribute. So how do you determine what should be in an iteration? You might be asking. I have 4 questions that I want to leave with you for self-reflection when it comes to iteration in your projects. The first question is you need to ask yourself, what is the purpose of your iteration? What are you really trying to do in your first iteration? That's really important because that will determine how big of a scope it is and how long it's going to take. Number 2 is that you want to make sure that and check whether the scope can be made simpler. There's always scope that can be reduced, but that plays hand in hand with the first question. If we reduce the scope even more, does it really fulfill the purpose that we set out to achieve in the first place? The third question is, what are the side effects of your iteration? Sometimes iteration has weird side effects, whether it's with your code or with other teams, they're trying to do other initiatives. So it's important to know the side effects because that will impact whether you can revert it or not in case your ship is sinking, like the GIF from earlier. And then the fourth question, similar to the third question, is asking yourself, is it easily reversible? What steps would need to be in place to revert it in case of a disaster? And so with that, I want to leave with you guys that everyone can iterate. It doesn't matter whether you are a CTO or you're an intern, you have the power to iterate. And I want to encourage you to do that because that will make you a better engineer, will help you understand the product, help you deliver things more effectively. And thank you